We introduce SeePerSea, a novel 3D maritime perception dataset for autonomous surface vehicles. There has been tremendous progress in deep learning-based methods for navigation applied, for example, to self-driving cars. This progress is thanks to the availability of datasets that enable the training of the models for obstacle detection and tracking, the fundamental task for autonomous navigation. More specifically, there are well-known benchmark datasets such as Kitty, Lucene, and Waymo in the self-driving car domain. However, in the maritime domain, there is a surprising lack of the comprehensive dataset for 3D perception. 1. The majority of the dataset consists of only images. 2. Existing multimodal datasets are not for detection or classification, which missing egocentric perspective and ground truth annotation of the object. Therefore, we open sourced the first maritime perception dataset collected over 4 years with over 10K frames consisting of multimodality. Our dataset has the following characteristics. First, we collected our data via different vehicle platforms, including our custom AS-based catabots and human-driven boats equipped with diverse sensors, RGB camera, LiDAR, IMU GPS compass. Next, our dataset covers diverse geographic locations, including seawaters in Barbados and South Korea, and freshwaters including lakes in the US. The following video shows the collection process at each environment with our platform. Unique to maritime robotic datasets, the collected data includes diverse objects that are labeled according to the international organization and rules. In addition, our dataset includes a diverse time of day, such as day, dusk, night. We provide the ground truth labeling of the object for both RGB and LiDAR. To validate the utility of the dataset, we have tested different state-of-the-art perception algorithms. First, we tested the image-based benchmarks such as the YOLO V9 and RTD-TER. The results shows that the state-of-the-art methods are good at detecting ship objects, while there is room for improvement for small objects such as buoys. Here, the quality results shows some challenging scenarios such as heavy traffic and ships docked together. Next, we tested deep learning-based detection algorithm, including LiDAR-only method and RGB LiDAR fusion method, covering different classes of methods such as sequential and feature-level fusion. Fusion-based method demonstrates superior performance across most metrics, while they need improvement to overcome the sparsity of LiDAR and misalignment. In particular, focal comb achieved the best performance because of the seamless integration of the complementary sensor modalities. On the other hand, point RCNN, which solely relies on low-point cloud, is less effective in sparse maritime environment. In summary, our paper introduced first publicly accessible multimodal perception dataset for autonomous maritime navigation, focusing on in-order obstacle with aquatic environment to enhance situational awareness. We provide diverse object and environmental conditions. We also analyze the performance of the current deep learning algorithms on our benchmark dataset and provide insight on current strengths and gaps that should be filled. As a future work, we'll incorporate object tracking and continue to develop full pipeline components towards high society impact. Thank you for watching our video.